Europe and I come and do courses like here. And I was in Paris about 3 years ago, I think. And I came there relatively late in the evening. So I typically travel after work. So I was there, I don't know, 11 o'clock in the evening. I fell asleep, and around 2 o'clock, I heard some really nasty buzzing. And it was buzzing, it was buzzing, it was buzzing. And then I started looking around as kind of, I can't be that drunk. I drank a bit, but this is really buzzing quite a lot. And I got up. It was still buzzing, so I kind of opened the door of the room, and then I heard sirens like the Germans are invading and everything in the hotel. It was kind of strange, and I thought, wow, this is kind of some burglar alarm or something like that. And then I thought, well, burglar alarm in a hotel, that doesn't make any sense, and I closed the door and went back to sleep. And then in the morning I realized that I've slept over a fire alarm. And I've kind of called the people downstairs and said, you know, has there been a fire alarm in the middle of the night? Yeah, there's been a fire alarm. Somebody left the bathroom door open and there was a lot of steam and we had to evacuate the whole building. And I realized I was probably the only person that remained sleeping in that building that day, where everybody ran out in the middle of the night and then sweat because they had to go back in and probably wanted to kill the person that left the bathroom door open. And I realized kind of the fire alarm didn't really scare me at all, because I became immune to alarms. When you go on a street and you hear a car alarm going on, the first thing you think is not, oh, somebody's robbing a car. The first thing you think is another idiot left the car alarm there. You know, I wish somebody would actually steal that car once. Or, you know, when in the middle of the day you hear somebody's shop burglar alarm go off and go there for, you know, just keep ringing for 10 hours until somebody comes and shuts it off. It's not that anybody's burgling there, it's because there's a bug in software or somebody triggered it or something like that. And I realized that kind of, that's insane, because people have put in alarms to scare people when the building is burning. And a fire alarm that's electronic probably doesn't do anything for me. I've survived too many exercises where kind of somebody says in the building, I don't know whether you have this in Estonia as well, but in the UK it's very popular. Every Monday they say, now we're going to test the fire alarm. And then they sound it for 15 minutes and then everybody has to go out and then you congratulate each other that you're still alive, you survived the alarm, everything is fine. And then when a real alarm goes off, nobody's going to run out of the building, because people will think that's a test. So kind of the real alarm, when digital alarms go off now, we don't pay attention anymore. We've been conditioned not to pay attention. If there was somebody screaming fire, we would probably run out. And this is the same thing happens to software. Because every single company I visit, I find, okay, there's a broken build on the monitor, nobody cares about it. Or we've had 60 critical bugs before a release found, and we still went and did the release, and then it blew up in production. And then people complain that, you know, why didn't we not take care of this and things like that. And this is insane. I think the things we track in software, the way we measure software quality is very much like that fire alarm in a hotel that people don't care about anymore. And what we need to do is we need to stop tracking stupid things that we've invented. And a lot of the stuff we've just invented, it doesn't matter at all. And we need to start tracking things that make sense. So, or for example, things like code coverage and things like a number of bugs. So everybody tracks that. And that's insane. That doesn't make sense at all. We've invented that. Those are just indicators of system health. And by trying to kind of cut down on the number of bugs, or track the number of bugs, or track code coverage and things like that, what we're actually doing is we're measuring an indicator that is not that important to the business. So that's very much like saying that, okay, blood pressure is a measure of health. And high blood pressure is not good. And what we want to do is we want to reduce blood pressure. So the easiest way to reduce blood pressure is cut somebody's head off, blood pressure goes to 0. But that's kind of completely defeating the point. So a lot of these things we've just invented ourselves. And we track that because they're easy to track. And Doug Hubbard wrote a book on measurements in business, and he said that basically people measure what's easy to measure, not what's valuable to measure. And then they invent value around stuff that's easy to measure. For example, bugs. So a lot of these things are actually kind of, I heard somebody call them Berlusconi metrics. So they're called Berlusconi metrics because kind of they're fun and they jump around and things like that, and they're amusing, but at the end of the day, they're completely irrelevant. And I kind of found one fantastic Berlusconi kind of quote-unquote code coverage, and the man himself kind of gave this quote-unquote coverage. He said kind of when they've asked him, you know, when he asked women whether they would like to sleep with him, 30% said yes, 70% said why, again. And this is kind of what we do with, for example, code coverage. We measure stuff that, okay, now we're at 80%, or now we're at 95%, or now we're at 70%. And it moves around and it's funny and it's everybody's happy with that, and then we have tools for that and things like that. It's just an insane waste of money. So the reason why that's an insane waste of money is that it is only amusing to developers to do that, and nobody else cares, really. So what we need to do is we need to find metrics that actually motivate people to take action. If you have code coverage that stays at 50%, goes to 70, goes down to 60, goes to 90, and nothing really ever happens, that's not motivating people to do anything. If we have, for example, metrics around bug trends that nobody ever does anything about, those are pointless metrics. We're wasting a lot of time there. So again, Doug Hubbard wrote that basically the value of a metric is the value of the decision it informs. And I've used that trick several times to refuse building reports. When business people come to me and say, we want reports, and what data you want to report? Everything. What report do you want? All. And now then you ask them, okay, what decisions will you be making based on these reports? It turns out they don't really need the reports anyway. So a lot of the people I worked with have now installed Sonar and things like that. So who has Sonar installed? One person. Okay. Then there's not much point slugging it off. Again,
you need to have a submarine before.
Yeah, well, Sonar is quite an interesting tool because it allows you to track 7 million metrics. And I've seen people measure all that and have lots of screens of data that moves around, but nobody ever does anything about that. It's just metrics. So we need to find things that motivate people to make a change. If we're going to create good metrics around software quality, if we're going to create if we're going to invest money in something and measure it and show it to people, we need to do something that actually motivates people to change, to improve quality. We need to do something that actually informs decisions. Otherwise, just measuring stuff that nobody cares about is a waste of time. So what I'd like to suggest is we do stuff that informates people. We need to find metrics that at the same time inform and motivate, so we can support a change. So this idea comes from a book called Switch that is about organizational change. And they say that a lot of organizational change fails because it's just based on information. We try and inform people that something is bad or something doesn't work, and nobody ever changes because there's a lack of motivation. And they use this analogy that I think works quite well for organizations. They talk about organizations being like an elephant and a rider on an elephant, and that the kind of the brain of the organization, all the data we want to put there is the rider that wants to take the elephant somewhere, but the organizations, our teams we work with, are essentially an elephant that if they want to go into a river, they will go into a river regardless what the rider tries to do. And there's a couple of really interesting case studies of organizational change in the book called Switch. And one of the most interesting studies I found there is from John Stegner. It's called Gloves on the Boardroom Table. You can Google for that. And it talks about a situation where some accountant in a relatively big American company realized that the company is actually buying 424 different types of work gloves that are essentially all used for the same purpose with 425 different prices, ranging from something that's very cheap to something that's very, very expensive. And he realized that this is completely insane and he needs to get the company to change. So he sent around lots of spreadsheets, nobody ever did anything. He sent reports, nobody ever did anything. He scheduled meetings and told people that they're wasting, and they were wasting about $1 billion in total in kind of similar things, not just gloves, but buying things differently. That's real money they could have saved. He sent around reports, Excel spreadsheets, nothing ever happened. And then he realized that if he wants to change the organization, he needs to motivate people as well. So he found 424 types of gloves, attached 424 prices on them, and actually put them on the boardroom table of the company, where they were very, very visual. And people were walking around and saying, well, you know, what are these gloves doing here? And basically said, this is how much different types of gloves we're buying, and these are the prices we have, and that's the difference. And then he said that people started saying, this is crazy. The board of the company started reacting to this, and the gloves became a traveling roadshow. They were taking this exhibition to all the factories of that company so that people can see what kind of madness this is, and the company started changing. He actually motivated them to change. So if we do want to improve quality in our teams, if we want to motivate people to change, we need to find the equivalent of this. And just displaying numbers that nobody cares about, or displaying numbers people do care about, but displaying them in a way that is kind of not motivating anybody to change, is essentially a waste of our time. So, and one of the things that I've been doing over the last year and a half is actually trying to collect how people approach visualizing quality. This is what John Stegner has done. He's visualized the problem. That's why it became a motivator, and this is exactly what we need to. We need to find ways to visualize what quality means for us and actually start changing the organization. So, my problem with bugs, and I've talked about bugs several times and people don't really get that. My problem with bugs is that, again, bugs are something that software people have invented. And we overinvest in that. We're obsessed with bugs. We measure things with bugs. We try and kind of fix bugs. We have brilliant systems for bug tracking and things like that. And one of the things that when I've started thinking about this as a problem was when I published my last book. So I've published a couple of books so far, and the one before the last I self-published. And that meant I could do whatever I want, which meant I created a continuous build pipeline for the book, built book from the XML, built PDFs. I found a copy editor that fixed up all my grammar and problems in the XML. I could diff, I could do everything developers want. Brilliant. The book went out, and then I kind of read it after it went out. It maybe had 1 or 2 typos in it. Then my last book actually went through a relatively big publisher, and they had a process that was completely different. They had a process where I wrote stuff in XML, then somebody copied and pasted XML manually into Word, which makes no sense, but that is their process. And then they printed that, then somebody on paper fixed up grammar and spelling, then somebody else put that in Word, then somebody took that and assembled in FrameMaker a PDF, then somebody went through the PDF and looked at all the problems that came out, then they sent it to me. Then I started looking at it, and on page 5 I found half of a word missing. And I sent it back. And then they sent it back to the people that assigned PDF, and then they sent it back to the people that did stuff on paper, and then they said, da, 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 and it was just insane. And at some point, because the book was about 6 months late, I said, look, if we don't get this out next month, let's just stop doing it, and I'll find another publisher. And said, no, we'll get it out by next month, and the book went out. And then when I received the book, I actually opened page 5 and found half of a word missing. And then I found on page 7 that there's an image covering a word. Then on page 10, there's a word that starts, and in the middle of the word there's a new sentence. It just stops, and kind of, I got really annoyed, and I wanted to write an angry letter to these people, but I wanted to have ammunition. So I spent about a month and a half very carefully reading the book. And I found 27 places where they've damaged the reading. So there's a half a word missing, or half a sentence, or an image is going over a word, or something like that. Priority 1. You can't read it. For a book, that's priority 1. Then I found 74 places where they've not hidden a part of a word or damaged the word, but what they've done is changed the meaning. So there's 74 sentences in the book where the sentence says something I didn't want it to say. There's a sentence that looks like I'm telling people selenium is bad, which I'm not. And there are 58 places in the book where they have changed the sentence so that it's a lot more difficult to understand. It doesn't change the meaning, but it's a lot more difficult to understand. And then I sent them this angry email. I said, this is stupid. How could you do this? It's a horrible thing. We need to change this straight away. Fix this and you know, republish and things like that. And I said, okay, that's okay. You know, once the next printing goes out in 6 months or so, when we sell out this, we'll change it. And I said, no, but you don't understand. It's horrible. You know, people will burn this book and you know, they will write angry blog posts, and I will never be able to show my face again and things like that, because people think I don't know English, which I don't, but that's fine. Kind of and the publisher basically said, that's okay, don't worry about it. I said, but it's not, it's my reputation, it's not. And he said, no, you know, that's okay, don't worry about it. The book is selling quite nicely. I said, but what do you mean? I said, no, don't worry about it. The book is selling quite nicely. Nobody's going to write an angry blog post. I said, but you don't understand. This is stupid. I said, no, look at Amazon. And on Amazon at that point, there were 21 5-star reviews. No 4, 3, 2, 1-star reviews. So kind of going back to this problem here, what I thought was priority 1 was obviously not priority 1. What I thought was priority 3 was obviously not priority 3. Because nobody complained, it was just me. And this is what we do with software all the time. We have people that are listing things as priority 1, 2, and 3, inventing 700 bugs that needed to be fixed and things like that, where very few of them actually are meaningful. And we overinvest. We overinvest horribly in tracking these things, managing these things, fixing these things, and a whole thing is insane because we invented it. Like I decided what priority 1 is here, we decide what priority 1 is based on our understanding. And the fact that the book sells quite nicely or that the software is quite well accepted doesn't really matter to us when we invent these metrics. So I think we're in a position now that we're getting the Western role problem in software, in particularly related to software testing. So does anybody know what the Western role is?
Yeah, it's a jumping style.
It's a jumping style.
Give me a book.
I'll give you a poster.
Sorry, I cheated. I watched the video.
You watched the video, okay?
Thanks anyway.
So thank you then for watching this again, but after watching the video. This is really good. I have fun. That's fantastic. So are you sure there's nothing more interesting for you to do tonight? You will see tomorrow, okay. So Western role is a jumping style. And what's interesting about Western role is kind of, Western role was the best practice. It was the jumping style. If you wanted to do jumping, that's what you had to learn. For 30 years or something like that. And then people realized it doesn't really make sense. And this is what's happening to software quality at the moment. So kind of high jump started in about 1908 or something like that, and the first thing was the scissors technique, which is kind of the logical way to jump. So if you had to jump relatively high, kind of this doesn't work, so you have to raise your legs, and I'm not going to try and do that now. But then this is what people used to do. So they started running and then jump one leg, jump another leg. Brilliant. Until one guy came around and said, well, kind of this guy, Doug Fosbury said, Duncan McNaughton basically said, what I'll do is I'll run and then I'll raise both my legs at the same time. And then people said, oh, what do you mean? That's insane. Raise your legs both, you'll fall, you'll hurt your head and things like that. Nobody jumps like that. That's stupid. And then in the Olympics in 1932, basically, that's what he did. He ran, he raised both his legs at the same time, he rolled over. And this was kind of the straddle technique, which was later improved. And people started improving on that and jumping over, curling and things like that. And they spent years and years gradually improving that. And then Doug Fosbury came in 1968, so about 30-something years later, and said, what I'll do is I'll basically run, and then I'll jump backwards. And people said, you're crazy. How is that going to work? Jump backwards. And basically, everybody jumped the way they were used to jump because they were improving this technique for 30 years. But they were improving it by maybe a few centimeters by rolling a bit like this or a bit like that. Then he came around, he ran, and he jumped backwards. And he jumped 15 centimeters more than anybody else. And all of a sudden, people stopped laughing, and they said, okay, so we're no longer going to run and jump with both legs, now we're going to jump backwards. And it's funny that this thing that was absolutely the best practice, everybody believed that. Every coach trained that for 30 years, every Olympics champion did it for 30 years. This was the best practice. All of a sudden became irrelevant. That's because somebody found a way to jump higher. And since '68, basically all the Olympic gold champions were using the Fosbury Flop. And probably, in a few years, somebody's going to come up with another technique because they've improved this thing gradually with a few centimeters, but very, very small. Somebody's going to come up with something else that will allow people to jump even higher. Now, this is where we are exactly with software quality and bugs and tests and things like that. Because, for example, here's your Western roll. So how many people have automated tests? About half of the room. So what would happen to your software if you just disabled all your tests? How long would it survive? A week? 2 weeks? Would you be confident releasing to production at all?
100 years if we don't change it.
Not if you don't change it, but with the rate of change you have at the moment. Would you be confident releasing it next week, in a month's time, 2 months? When do you lose all your confidence? How quickly?
After first change. After first change.
After first change, okay, maybe. And the thing is, how much does it cost you to keep these tests up to date? How much does it cost you to maintain these tests? How much does it cost us to keep writing these tests? How long does it cost us to run it? How much does that delay what we release? So I've talked to a team that basically disables all their tests after a release. They write their tests to guide development. Once the tests are passing for the first time, they disable them. And I thought, these people are completely crazy. How can they do this? They're going to fall on their head. Like people have told Doug McNaughton he's going to fall on his head, or Doug Fosbury that, he's going to fall and not jump. These people are insane. How can this work? But actually, it works quite well. What they're doing is they're releasing several times a day, and they're not paying for the cost of test maintenance. And because they're releasing several times a day, they couldn't even run all their tests several times a day. That's how many tests they have. So they had to come up with something more important. And what they came up with is basically every time there is a software change, the business users have to say what that is really going to change to the business. For example, they can say something like, if we do this software change, the number of user conversions is going to go up 10%. Or the number, the Google is going to index us better, or we will get this many more visits or something like that. And it has to be one of the core key performance indicators they have set together with the business. So what they will do is actually they will develop this using test-driven development. Once it is ready, they will disable the tests. They will roll it out to 10% of their machines and measure the effect. And they will measure whether they have 10% more customers there, or whether Google is indexing that thing better, or whether they are earning more money through what the business expected, and if not, they will just roll the whole thing back. It doesn't matter if it's a software bug or a misunderstood requirement or the business having the wrong idea, they will roll it back. It's not good. If the key performance indicators increase, they keep it and they roll it out to the rest of the farm. And they're measuring these 5 or 6 key things that the business cares about on production on 10% of the farm. So, kind of, yes, this is insane. And many people working in back office systems in banks in particular are going to say, this makes no sense. We will never be allowed to do that. And this is irrelevant for what we do and things like that. But 10 years ago, people were saying the same thing about 2-week iterations. They were saying, this is insane. We wouldn't be allowed to do this. We're a bank. We do our cycles 1 year and things like that. And now, most of the teams I work with in big banks are actually releasing every 2 weeks. So the kind of crazy web thing is catching on. We're just a bit later because these people have found a way to jump higher. These people have found a way to measure things that really matter to their business, not to measure that if you click on this button and the wrong message pops up, oh, that's a bug. And we have 700 bugs in Jira. And they're never getting cleaned up and things like that. So, and also these people have found a way to unify the kind of software problem, business problem, technical problem, it doesn't matter. If it brings down the number of users on those 10% of the system, it is bad. If it increases it, it is good. So that's kind of where we are going at the moment as an industry. And I think if you look at the last 10 years, the delivery phases have shrunken more and more and more. So most teams I work with these days have a delivery phase of about 2 weeks, where a lot of them actually have delivery phases that are less than that. Several teams I work with have delivery phases that are inside the day. And when we start talking about that, we are getting into the same problem as people had when they've moved away from a 1-year release cycle to a 2-week release cycle, where we can no longer maintain tests like this. So we have to automate. Well, in this case, we can no longer afford to run all our tests, or we can no longer afford to maintain all our tests. That costs too much. So this is kind of what's waiting for us. And I would assume that in about 5 or 6 years, most people in this room will actually suffer from this problem. So what can we do to prepare for that? And where do we start changing this thing? Where do we start stopping investment in things that are no longer needed? And how do we engage our business users in something that helps us define 5 or 6 things, as these people have found with the key performance indicators, that we can actually use? So the key problem here is that the absence of bugs is not really the presence of quality. They're two different things. We can measure that we have no bugs, but it still doesn't mean we have quality. For example, look at Nokia phones. Nokia phones are technically built brilliantly. Nobody uses them. Does that mean they have quality? Or look at Twitter. Twitter falls down every 3rd day. Millions of users. So we can't really say that it doesn't have quality. It obviously does something for people. But if you would measure bugs there, I'm sure you'd have a fine time identifying 5 million problems. So we need to move away from this idea that by measuring 0 bugs or a low number of bugs, we've actually measured quality, because we haven't. Quality is something that matters to some people who matter, where kind of bugs are stuff that we invented. And they're just an indicator, and it's not a good indicator at all. So here's an experiment I'd like you to try. And this is what we've done at a company. This was a relatively large accounting firm that has asked us to come in and see how they can test their software better. The business users were concerned that testers are not doing their job properly. And typically, when we go into situations like that, the solution is relatively easy. It's either test automation. If they don't have test automation, if they have test automation, it's a different kind of test automation, or rewriting tests in a different way. However, these people had a relatively good level of test automation coverage. Then we were talking to developers to understand what the process is, and these people had a relatively good process. And the more we were talking to developers and testers, the more we understood that the problem isn't really there. So we did this experiment. We got the top 20 most important business people in the room. We gave them 3 index cards. And we told them to write the 3 things that are most important for them on those index cards. And then we grouped them. So this is an accounting firm, so everybody wrote accuracy. But then the other answers were quite interesting. We got about 40 different answers from 20 people, which meant that these 20 business people were pulling the development and testing teams in 20 different directions. Some people cared most about frequent releases. Other people cared most about stability. Somebody else cared most about getting the thing very, very fast. Other people said, well, we don't really care about getting it fast as long as it's compliant to standards and things like that. So when we showed this to these people, they understood how this is insane. Because there's no way you can pull a software team in 20 different directions and the software team delivers. And as a result of that, we got them to choose 5 most important things. And all of a sudden, they were able to test it quite good. The problem is never in testing. Testing never puts problems in. Testing can only show you maybe that you have some problems. But this was a completely wrong setup of the whole thing. And the setup, the problem wasn't in development, the problem wasn't in testing. The problem was actually much before. So we did something very, very similar to John Stegner's gloves on the boardroom table. We actually showed business people visually that this thing doesn't make sense. So this goes back to what Elizabeth Hendrickson said at Agile Testing Days last year. She said, no longer last year, this is 2012, in 2010. She said basically that people asking for control really want visibility. They don't want control. Business people that are micromanaging software teams, that are looking for lots of stupid reports, do not want that. What they really want is visibility. What's coming out, when it's coming out, how much risk there is in that, and things like that. And this is what we need to work on providing, instead of working with micromanaged control. And this then gives us a lot more time to do things properly. So one really interesting thing when I start talking to people about this is where software people, and I count myself as a software person, can often say that business people will never really understand if we talk about the level of risk in software. And if we talk about, okay, our release has this much risk in, do you want to, our software at the moment has this much risk, do you want to release it or not? They will never understand, they will never accept that. And testers in particular say, well, we can't release if we have a priority 1 bug and things like that. And this is quite interesting, especially when we talk about managing risk, because any software we have carries a certain amount of risk. By testing it, we are de-risking it. We are proving that certain risks are not there, but we can't test indefinitely. Testing is never finished. Testing is only stopped at some point. Regardless of whether you do it through automated tests, manual tests, this thing and that thing, we only stop it at a point where we decide we've covered enough risk. And again, the problem here is that in most organizations, developers and testers decide what kind of risks we need to cover, and developers and testers decide how we're de-risking that. If you don't believe me,
just continue. I'll comment later, maybe.
No, let's talk about this. So,
it's bad testing when stuff is done like that, like you talk about. Mm-hmm. It's not good testing.
Absolutely, that's what I mean. But most organizations I work with do it that way. Business people get engaged very early, and they give you some they give people some broad guidelines, and then testers decide on test cases. Testers decide whether test cases pass or fail.
bad testers then?
Okay, again, I agree with you completely. They are bad testers, but that's what most organizations do. So if you don't work in a situation like that, good for you. So, but in most organizations, at least the organizations I work with, testers are people in control of the test cases. They are the guys who actually define what's being tested. They are the guys who define how we're testing it. And developers kind of help a bit there. But essentially, it's kind of people providing their own metrics. The metrics that they've invented. Not metrics like sales. Not metrics like users. Not business metrics. Software metrics. So, and as I said, all software we have carries a certain level of risk. And what we need to do is we need to get an agreement with the business on how much risk they accept. Because for Twitter, obviously the risk of getting a server down is okay, as long as the users are there. For those people that I've mentioned that disable tests, obviously the risks of a few UI bugs are okay, as long as the user numbers are increasing, sales are increasing and things like that. So the business people will accept certain levels of risk. What a lot of people don't do is actually engage in a dialogue with the business on what's an acceptable level of risk and how to measure that. Because if we continue testing after that, we're actually wasting time. And we're wasting money. So, and again, lots of software people I talk to kind of dismiss this completely as our business people will never understand this. And I've had recently a case where we've talked about this. There was an organization, their delivery phase was about 6 weeks long, out of which 4 weeks was testing. And we said, this is insane. We need to cut down on the testing time. And we need to cut down significantly, and the business will have to accept a certain level of risk. And they said, the business will never understand what you talk about. So the joke here is that these people were an insurance company. Their whole business was managing risk. The business people were actually very, very good in risk models, but software people assumed, oh, they'll never understand anything like that. So kind of what I think we should work on to actually help people understand how much risk they carry is start visualizing things that they might care about. And this is very contextual. I don't know what's going to work for your company. I can only give you ideas that I've seen elsewhere, and then it might or might not make sense in your context. But I started collecting what people do to actually visualize the quality. So there's kind of lots of people measure and visualize the effectiveness of their software process. I think is again an indicator, but it might be a good indicator if you say that your average release is every 4 hours. That's a good indicator that you can react to problems quickly. The other things that people measure is kind of the status of their product. What is the bug level, coverage level, and things like that. And there are certain things that we can actually do to show the level of risk. And that's not kind of priority 1, 2, and 3 bugs, but actually showing people what is the risk and to what. Is it a risk to sales? Is it a risk to people registering? Is it a risk to kind of getting new users and things like that? Not, okay, it's a priority 1 bug. And the third thing people measure and monitor and visualize that's very, very interesting is production performance. So, again, an example that comes to my mind that's interesting is I've worked with one of the biggest media companies in the UK to redefine what kind of they use as testing, because they've moved to Agile, whatever that means in their context. It wasn't what you mean. And their move to Agile was actually, we're going to have developers developing until Friday afternoon the second week, and then testers are going to go off on 4 weeks of testing. Or something like that. It's brilliant. And then we talked about, okay, what do we really need to do here? And we decided that the company actually has a budget of 2 days of testing per cycle. That was the budget. Because the way they were doing things, they had to stop development to test. That's a different story, but we said, okay, 10% of our iteration, that's doable for testing, that is the budget. So we need to cut down any testing effort to 2 days. And we started looking at what do people actually care about, using one of the techniques I'll show you. And we've realized that, for example, a lot of the complaints are coming about a publishing system that the business users think it's very, very buggy, it's problematic, there are always problems with that, they want to rewrite it. And we realized that kind of going back to Elizabeth Hendrickson's idea, we said, okay, is there a visibility thing missing? And they said, what do you mean? I said, well, how would you visualize the problem? And they said, well, kind of sometimes they publish an article and the article gets published immediately. Sometimes they publish an article, it doesn't go out for 15 minutes. Then I think there's a problem, I publish it again. Then I think there's a problem, I publish it again. And then in 45 minutes, the same article appears 3 times on the homepage. Because the system was scheduling other updates from other content managers and things like that. And developers were often complaining this system is falling over, and this wasn't a good system at all. But what we did is we bought a couple of big monitors and we displayed how long it took for the last article to get published. And there was one big monitor in the content manager's room, there was one big monitor in the developer's room, showing that the last article that went live in 5 minutes or 15 minutes or 10 seconds or 30 minutes. And what this did is people stopped complaining. There were no bug reports anymore. It wasn't that the system was good. It was the same system. People stopped complaining. Because now they knew that when they publish something, it's going to go in 45 minutes. And developers looking at this would say, whoa, why is it taking 20 minutes? I'll look at production and sort it out, even before people complain. So just by visualizing this thing, we were able to help them improve the quality without touching the system. Because we were showing something that business people care about, and we were measuring something that business people actually care about. So people could take action on that. So the when I talk about measuring product status, there's a couple of things that I would suggest you look at. It might make sense or might not make sense. So one thing is, was invented by James Buck about 10 years ago, and it's called the low-tech testing dashboard. So low-tech testing dashboard basically avoids the problem of 5 million bugs in Jira that nobody ever looks at, that have some status reports and things like that, because it's just too much information. So James Buck said that typically we just kind of overwhelm people with information. Just like John Stegner sent people around a spreadsheet of things they were buying, and they don't react to that because it's just an overload of information. So he created this idea that basically you break the system down into several areas. On a high level, you show whether the status of your testing is we finished testing, no problems at all, or we started testing, we don't know yet, or we found some problems. And by summarizing information like this, you kind of show what the risk is there in this subsystem and some notes. This was more than enough for business people to make good decisions whether this thing is acceptable as a release or not. Again, ideally 0 bugs. But maybe we're over-investing. Maybe a bug in this system here, perfectly okay if it goes live. We are getting faster time to market. The Google for Low-Tech Testing Dashboard, this is a very good way to summarize the results of testing to business people. So the other thing that a lot of people do are hash maps or heat maps or charts of risks and test coverage, where this is one example that Claire McLennan sent me, where, for example, the gray thing is the amount of risk that a certain system carries, and the green thing is basically the amount of tests that are passing at the moment. And people can look at this and say, well, you know, quite a lot of risk in this area, we can't do a release, so yes, it's okay, we can do a release. I've done a very similar thing for an investment fund where we've looked at a migration from a legacy system to a new system, and we've covered lots of different trade types and things like that. And we said, okay, where is the risk here? And he said, what do you mean? I said, well, we have lots of different types of trades. Are certain trades more valuable than the others? And they said, yeah, well, 90% of our trades are equity trades. I said, okay, so if equity doesn't work, this is a big problem. Yes, Forex, 5%, this thing, 3%, less risk. Then we talked about, okay, what are some types of trades? And we said, okay, new trades, if they don't work, that's a massive problem. Cancellations, we don't have that much. It doesn't mean we'll break cancellations intentionally, But it means that if we can get faster time to market, the business will accept for a while that cancellations don't work. We can do it in the back office anyway. And then what we did is we overlaid a risk map with the map of things that were tested. And that showed us that, for example, we had 700 tests in an area that's not risky, and we had only 5 tests in some other area that was very, very risky. And now when we talk about an investment in testing, that tells you that we should really stop maintaining these 700 tests. And we should invest that time in writing some tests for that area that is very risky. But this was a risk that came through with an agreement with the business people. So then we decided, let's stop doing this, let's start doing this with that budget we have of our time for our testing activities. And another thing that's quite interesting that I use a lot is effect mapping. Effect mapping is a technique to get a shared understanding of business assumptions that is invented by a Swedish interaction design agency. And an effect map is a mind map of the scope of a project that basically starts with a business goal. Why are we doing this? Then the stakeholders that can help us achieve a business goal, then the business activities that these people need to do, and then software features that support these business activities. So what's interesting about this is it actually captures what software needs to do from a business perspective. For example, on this map here, we know that semi-automated invites help players invite their friends, and what we expect is if they invite friends, more people will come. And this gives us something to measure from a business perspective. When I roll the system out, I can actually measure whether more people are coming. And if not, I can argue with the business that they've made the wrong decision about this. And we should take it out. It's low quality. It's not low quality because it has 5 bugs. It's low quality because people are not coming. This is what we need to do. Likewise, when we do testing, this is what we need to prove. We need to prove that semi-automated invites allow people to invite their friends. There might be 20 different bugs in semi-automated invites, and as long as they're not impacting inviting friends, I don't care. I need to prove that this thing can serve the purpose that the business wanted to do. So effect maps help us capture assumptions of business people very nicely, so we can actually test these assumptions. And we can then push back on bad business decisions. We can prove that certain decisions like these user stories were a waste of time. Let's stop doing that because it's not contributing to the business goal. So another example that some people have sent me is a FERPS Plus mind map. So FERPS Plus is basically a mind map that has several branches. One are functional important things. These are things important for usability. Then we have reliability, performance, supportability, and plus is everything else that people care about. So lots of teams do FERPS Plus maps where basically they get the business people together, draw these 5 things and say, write down what you think is important in these areas. And then this becomes what we need to prove. This becomes what we need to test. It's no longer our invented bugs. Another thing that's really, really interesting that the people at Google have invented is called the ACC Matrix, Attribute Component Capability. So Google uses this to manage lots of their testing stuff, including the Chrome OS and Google Maps. And the ACC Matrix is, it goes in the similar direction as the QFD House of Quality, but it's a lot easier to use. What it does is it captures a shared agreement with the business on the level of risk certain things carry. So the ACC Matrix basically has 3 dimensions. One are the attributes. These are what business people care about. Is it fast? Is it secure? Whatever it is in your context. Then the vertical here are capabilities. What does our system allow people to do? And this area here are components. So what parts of our system, what parts is our system built of? So when you have something like this, typically on relatively large systems that I've done, this is 10, 15 attributes. There's a couple of hundred of these, and there's 10 or 15 of these components, maybe. And then what we do is we get the business people to weight the risk and importance on the intersections of these things. How important is it for managing profiles to be fast? How important is it for managing profiles to be secure? And then this becomes a shared understanding of the business people, first of all, where is the risk and what's important. If you have 20 business people pulling the system in different directions, this is a very good way to get them to agree what's really important. And then what we do here is we map out whether a component is actually participating in a particular activity. And this is telling you, if you want to prove this thing, this is what you need to test. And you can fill up the matrix with the number of tests you have for certain components that are de-risking that managing profiles is fast. So what I've done with this is, for example, help people move away from comfort-based quality to evidence-based quality. The Forrester Research recently published a survey of how people do Agile. And they said that the most frequent way companies do Agile is something they called water scrum fall. Which means that there is a huge period up front where the business people make business decisions and wear suits and do lots of good stuff. And then there's a short period where their children can play with Scrum. And then there's a long period after that where the business people wait for acceptance. So one company I worked with recently, basically they told me that they have a 2-week Scrum. And they're doing a 6-month release cycle with 2-week scrums. And when we looked what they actually do. They had 1.5 years of getting the business case approved and decided and modeled and things like that. Then they're going to have 6 months of Scrum. And then they plan to do 3 months of validation, whatever that meant. And I asked, well, this is testing, this is waterfall. No. Testing is inside iteration, this is validation. So, I've seen many less drastic situations like that, but people often have this kind of, let's keep it for a while on the staging system until it marinates. And they have some statistics, historically, that if they keep it in the staging system for 2 or 3 weeks, it becomes stable enough. So this is kind of mostly comfort-based quality. When you tell people, well, what are you doing those 3 weeks? Well, we check it. What do you check? Well, kind of we play around with that. And then we feel comfortable. So this doesn't scale. If you want to have a proper release cycle of 2 weeks, you can't have 2 weeks of marinating on a server. Or if you want to have a cycle that's less than a day, that becomes completely impossible. So what we need to move away from, we need to move away from comfort and move into evidence-based quality. And I've done the ACC Matrix several times with people like that to say, okay, let's go through your 2 weeks of marination and let's see what you're actually proving there. Let's mark it up here and let's say, okay, this is what we need to prove. And then when you do something like this, what actually turns out very often is that they're not proving some stuff that's really, really critical. And this gives people a good understanding what we need to do. So what Google does with this is actually they drive their testing effort. So you can Google for ACC Matrix. James Whittaker talks quite a lot about this. And he was writing a book, How Google Tests Software. It was supposed to come out. And I've seen a couple of weeks ago that he's actually quit Google. So I don't know whether that's getting completed or not. But if the book ever goes out, you'll be able to read it there. There's also a couple of videos of him explaining the ACC Matrix. But for example, in Google, at least the teams he talked about, developers are not allowed to ask for testers' help on anything that's below level 5. Because the testers get engaged only when there's enough risk for this thing for them to test. They also use this to drive their testing ideas. So for example, they've defined tours. Something like high value tour would mean go and test all the 5s. And something like they have something called a Scottish bike ride, because apparently nobody in Scotland rides a bike because it's too cold. So the Scottish bike ride is let's go and test stuff that nobody's really looking at. And they have an agreement that they're doing a Scottish bike ride every 6 months or something like that. But you can actually have much more meaningful conversation about what we want to do in terms of testing and quality when you have an agreement like that. So one really interesting thing that this allows you to do is visualize it. So they have lots of radar-like visualizations and things like that, but what's one that really I love is something like this. So this is basically the ACC Matrix folded into a 3D landscape, where the deeper the hole is, the more risk you have. And they have this live on monitors, changing all the time, feeding from their test reports. And kind of the more tests are passing, the less risk there is. And they have an agreement with the business that once all the risks are above level something, they can release. And this is kind of a live visualization. So you can find a lot more about the ACC Matrix on this URL, and I'll give you another URL later, but this is a fantastically powerful tool. They've recently open sourced the tool they use to manage the ACC Matrix. It's called Testify, I think. A lot of people I worked with actually just use Excel for that. You don't have to have a big massive tool where you put things. So another thing that's really interesting that I found as a good visualization is what the guys from fin.no do. They've basically plugged in a Twitter feed that looks whether people are writing good things about them or bad things about them on Twitter. And they have this in a big monitor that is basically green or red, whether people are writing these guys are idiots, everything is broken, oh, this is the best system in the world. And this is a measure of quality they have. This is kind of the end-to-end users are happy measure of quality. So there's, I know that there's a commercial tool that does this now. I don't remember what it's called, but I'll give you a link where you can find it. So these are some ideas that hopefully inspire you to look for better ways of actually communicating quality, and for more meaningful ways that business people can actually understand and relate to and tell you that we don't need this, so yes, this is really, really important. So kind of what we can do next with this, and what I expect is going to happen over the next 5 or 6 years with many teams, is first of all, by actually trying to visualize holistically what quality means, we can get people to pull in the same direction. If you have lots of stakeholders that are pulling in the wrong directions, different directions, or kind of testers saying that, oh, this is critical, it has to be fixed, and developers saying, well, it's not that important, or developers saying, I have to fix this thing, and everybody else is saying, well, release, 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 this will actually help us pull in the same direction. When we have a good definition of what quality means, then when a developer says, I have to fix it, and everybody says, okay, that's risk 8, go and fix it, or when a developer says, I have to fix it, and it's actually risk 1, I don't really have to fix it. So another thing that I've seen lots of teams do is move away from comfort-based quality into evidence-based quality, which is a really powerful thing to do, because then you start thinking about what do I need to prove to show you that we have quality, and then we don't have to marinate our software. And by eliminating that, people really become a lot more productive. So the third thing that I think this will help us do is do a proportional investment in quality, proportional investment in developing, not just testing. But if we understand that something is risk level 5, importance level 5, we will invest more in developing software features there, in testing software features than in something that's risk 1. And the last thing is, I think, in particular effect maps and things like that, they really help drive product development, where we say, okay, this is quite important. We want users to come in, we want conversions, we want whatever are good business metrics for you. How do we do that? Rather than how do we implement 500 user stories that are in some Jira backlog somewhere? And how would we actually focus our effort on delivering things that really, really matter? So, kind of I said, those are some techniques that I've seen people do. They might or might not apply in your context. Or they might be a good idea to start investigating, but even if not, think about how you could get this agreement with everybody, business developers, testers, analysts, what's really, really important, what's really, really risky. And how do we start measuring that? Because unless we have that, people will invent their own measures of risk. For example, I worked recently with an accounting department of a large bank. And most of what they do are regulatory reports. And everything is a must-have. Everything is a priority one. Because if you don't deliver any of these things, you're breaking regulations. And there was no way to reduce anything from 4 weeks of testing or things like that. And we said, okay, if everything is a must and everything is important, not everything is equally important. Are we sure that out of the budget we have for testing and budget we have for development, we're actually investing in the most important things? And they said everything is important. I said, okay, let's think about it this way. So there's several ways of you can break regulations. Sometimes when you break a regulation, you get an angry email. Sometimes when you break a regulation, the director of the bank gets arrested. So with your budget for testing, which one do you want to test? And then we started really moving away from the idea that everything is equally important, because this is a bank, and if they pay a few €100 as a penalty, nobody cares. But if they need to pay 10 million, people do care. So different reports have different levels of importance. So just because everything is regulatory does not mean everything is equally important. So we need to have this shared agreement with the business. So kind of all the techniques I've shown you and the links to all the tools I've mentioned are on visualisingquality.org. And there's a lot more there. And I wrote a couple of articles about that. You can read them on my website. Kind of that's about it. I hope this is giving you at least some food for thought. Do you have any questions? Does anybody think this is completely stupid and insane? And sorry.
I have a question. The risk issue. Can you give us any examples how you measure it? I mean, in what terms?
So that is very, very contextual. That depends on the kind of work you do. For example, you know, there's a kind of a risk that people cannot really use your website at all, or that your product is sending wrong trades to the market, or that you know, the system is not allowing you to function normally. And there is a risk that maybe some back office operation will be impacted. So what I would do is I would actually look at something like this as an ACC matrix and list the attributes people care about, and then go through the activities and say, okay, so if update network is not fast enough, how big a problem is that? Will you be able to live with that? Will you be able, does it severely impact your business? Is it something there's a workaround? Is there a financial penalty for this? Is there loss of life? There are kind of lots of different ways people measure risk, and that really depends on what kind of software you do. If you're doing medical software, the risks are a lot different than if you're doing a trading system, and the risks are a lot different than when you're doing a Twitter-like website. But you can typically look at the money impact, the reputational impact, legal impact, things like that, and look where, you know, where are things going wrong. So there's a thing called the Kano model that is used very often in lean production to figure out what is the level of importance and risk of particular features. So the Kano model is relatively simple. It has a questionnaire you need to fill in. And then based on the questionnaire, you kind of compare things, and there's a matrix calculation there that gives you the level of risk. That's one thing that I typically try and do. So you'll find the link to the Kano model as well on visualisingquality.org. And again, very often businesses have a risk management department. Especially if it's a big business, if it's a bank, if it's a big company, people have the business risk identified. They're managing business risks anyway, so it's worth talking to these people about what are the business risks, what is kind of, where is the importance, because kind of there are two dimensions to this. Risk is one, importance is another. Kind of if you're opening a new trading system, if you want to go and trade in Brazil and things like that, time to market is quite important, because if you're there 6 months before everybody else, you will make quite a lot of money. Kind of there's a risk on the other hand of regulatory and things like that. So these things are very, very contextual. I don't, so what kind of business does your company do?
Geographic information systems, so it's a bit different. But
so okay, so I mean, if your information is incorrect, people will probably not use you.
Could be.
So and then the question is, then the question is kind of, you know, what information really needs to be correct, because you're probably presenting lots of different types of information. So, you know, a height of a mountain If you're selling to, I don't know, air traffic control is quite important. If you're selling to people who are driving around boats, not that important.
So what you're saying is that ask business people.
I think, yes, we need to engage with them. I think if they were going to give us this information, they would be giving us this information already. So we need to find better ways of engaging with them to get this information out of them.
Isn't this the strategy of Microsoft before they have started losing the market share?
I don't know. I don't know what the strategy was. So what was the strategy?
I think that they have had lots of bugs, so just users started leaving.
Gojko is a Mac user. So.
No, but okay, users started leaving kind of, I don't know, Microsoft makes money on Microsoft Office. People still use Microsoft Office.
Yeah, but if users start leaving and they keep as change, then they will look at those things.
So, again, you know, I don't know. I've not worked for Microsoft. I've seen about 20 Microsoft people on the plane when I was coming over. Tallinn is obviously popular with Microsoft people now, but I've never worked with them, so I don't know what the business strategy was, really.
You can ask Whitaker. He worked for Microsoft for a while.
He did work for Microsoft before Google.
Yeah. He did a lot of stuff there, but none of that was very good. So then he went to Google, and then, well, he has left now.
Well, yeah. So, again, you know, when we talk about kind of defining quality, that is completely contextual. And what works in one situation might not work in another. But kind of these are some good ideas that have worked elsewhere. So maybe they will work for you, maybe not. But if not, come up with another idea. And if you do so, and if you know about any other good techniques, please, this visualizingquality.org is a public wiki site. Go and edit it.
I have one question. We talked about visualization, but there are two kind of people. One eating information by eyes, and another people by ears. Audience. What do you suggest to audience for people who are?
I don't know. Connect it to an audio card and scream. So, if it screams loud enough, then it's a problem. I don't know. I mean, there's this whole heartbeat thing. You know, I know that in like surgical operations, you have a heartbeat monitor that pings, ping, 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 and then if it stops pinging, you know, there's a problem. So maybe something like that. Although they will probably annoy all the developers all the time if it's pinging. Maybe connect it to a fire alarm. It's actually going to be useful for something. If your build fails, then...
Okay, let's take one more question. Or not?
Okay. Thank you very much. I hope this at least provoked some thinking. Thank you.